Good day to everyone. I am Eugene Biabara and today I will be reporting about flow rate. But first, let me define to you what is flow rate. As the name suggests, flow rate is the measure of a volume of liquid that moves in a certain amount of time. Also, its current depends on the diameter of the pipe. Moreover, in this topic, you will learn about the flow rate formula, formula's derivation, and solved example. Flow rate. What is the difference that distinct fluid from solid? The answer is that in everyday experience with fluids like water and air, and slid like onion and potatoes, moreover, you may have sensed that a major distinction among these two categories of the matter is in the way they move. Objects like potatoes and onions are solids since they retain their shape when they are thrown. On the other hand, the air does not retain its shape while moving in and out of our lungs. Furthermore, the matter which is not solid is fluid, and their main property is that they can flow. In addition, fluids can move, and when they move, they change shape and volumes. But take note that their mass remains the same even when they are moving. Besides, the motion of the fluid is known as the flow rate. In simple words, the tendency of fluid to move from one place to another is of course its flow rate. Flow rate is the measure of the volume of liquid that moves in a certain amount of time. Moreover, the flow rate depends upon the channel from which the liquid is passing or the area of the pipe and of course the velocity of the liquid. Besides, the formula is fluid flow rate equals to the area of the pipe or channel multiplied by velocity of the liquid. Then we will get the equation Q is equals to A times V. And now, we will go to the derivation of the flow rate formula, where Q refers to the liquid flow rate measured as cubic meter per second or liter per second, and A refers to the area of the pipe or channel in m square, and V refers to the velocity of the liquid in meter per second. So now, pupunta na tayo sa example number 1. Suppose, water is flowing from a circular pipe that has a radius of 0.0800 meter. Furthermore, its velocity is 3.30 meter per second. So the question is, calculate the flow rate of water that flows from the pipe in liters per second. Solution. For finding the flow rate, first, we need to find the area of a circular pipe. Since madali lang sana nating i-derive to gamit yung equation na Q is equals to A times V, which is the area times velocity. Kaso kung napansin nyo sa problem, walang given na area. Kaya hanapin muna natin yung area ng circular pipe, which is pi r square. A is equals to pi r square. All we need to do is to substitute. A is equals to pi multiplied by 0.0800 meter, which is given, yun yung radius na ating circular pipe. So, gagamit na tayo ng ating calculator. Input natin pi times 0.0800 meter square. Huwag niyong kalimutan yung square pala. Square is equals to 0.0201 meter square. So, nakuha na natin yung area, guys. Ngayon, i-derive na natin gamit yung formula na Q is equals to A times V. So, the area of the pipe is 0.201 meter square. Now, we can find the flow rate. So, substitute lang natin. Q is equals to A times V. Yung area natin na 0.0201 meter square multiplied sa given na meron siyang velocity na 3.30 meter per second. Input lang ulit din natin, guys. Huwag niyong kalimutan, Q is equals to A times V. Yung area natin na nakuha, 0.0201 times 3.30. Yun yung velocity niya. At lalabas dyan ay ang 0.06633 cubic meter. Napansin nyo bakit cubic meter? Kasi yun yung unit natin pagdating sa flow rate. Furthermore, meron pa siyang next na question. Calculate the flow rate of water that flows from the pipe in liters per second. So, naka-cubic meter pa lang siya. So, i-convert natin siya. Since ang 1 cubic meter has an equivalent of 1,000 liter per second. Ang gagamitin lang natin this multiplication lang din ulit. 0.06633 multiplied by 1,000 liter. So, lalabas dito yung 66.33. Yun na yung ating final answer. So, the flow rate through a circular pipe is 66.33 liter per second. Huwag nyo kakalimutan na i-input yung kanyang unit. Yun lang guys. Thank you and I hope may naintindihan kayo sa report ko. God bless!
Hi, I am Jemima Kesha Apalya and I am reporting the mass flow rate. Mass flow rate is the amount of mass that flows through the pipe in a given time period. Concept of mass flow rate. The conservation of mass is telling us that the mass flow rate through a tube must be constant. We can compute the value of mass flow rate from the given flow condition. Mass flow rate is the rate of movement of a massive fluid through the unit area. Obviously, this flow rate depends on the density, velocity of the fluid, and the area of the cross-section. Therefore, it is the movement of mass per unit time. It is measured in the unit of kilogram per seconds. Thus, we can say that the mass of flow rate is the mass of a liquid substance passing per unit time.
Application of such relations are mostly found in mass balance analysis, which is an essential part of a controlled volume energy balance analysis in thermodynamics. And here, we can see two equations. M with a dot in the upper part is mass flow rate. This quantity ρ or symbol ρ is density. This cursive V with a dot in the upper part is volumetric flow rate. Mass flow rate equals to density times volumetric flow rate. We will see that the volumetric flow rate is equals to the average velocity and a cross-section in the flow in a controlled volume multiplied by the cross-sectional area. Okay, we are going to show this relation in a duct flow example. Here, I have drawn a duct showing the actual cross-section of the duct, and here, these thick red lines are the walls. Then, I am going to find a cross-section in this duct. Okay, I have drawn the cross-section using a blue line, and I'm going to look at the velocity distribution of the fluid flow in this cross-section. You will see something like this. Here, I have drawn the velocity distribution at this cross-section, and at this cross-section, we have the mass flow rate, volumetric flow rate, the average velocity, and the cross-sectional area of this section. And since the velocity of the flow is not uniform at the cross-section, studying fluid mechanics, we are going to learn about the viscosity factors of fluid flow. And you will know that the velocity flow is zero at the wall, and it reaches maximum in the middle of the duct flow. So it depends on the flow condition, either it is laminar flow or turbulent flow. The distribution will look slightly different. However, they are all similar in the velocity of the fluid flow, that is zero at the wall, and it reaches maximum in the middle of the duct. Now we know that there is a velocity distribution at the cross-section. However, from a mass conservation point of view, we can find the average velocity. We can think of something like this.
The mass flow formula. Mass flow rate is equals to density times velocity and times area of the cross-section. In mathematical equation, m is equals to p times v times a, where m is equals to the flow rate, p is equals to the density of the fluid, and v is equals to the velocity of the fluid, and a for the area. For the examples, a fluid is moving through a tube at a speed of 20 meters per second. The tube has a transverse area of 0.3 square meters. The density of the fluid is given as 1.5 grams per cubic meter. Determine the amount of mass flowing through the tube using mass flow rate formula. The solution is the total mass of the fluid flowing through the tube is given by the formula. M is equals to P times V and times A. P is equals to 1.5 gram per cubic meter. A is equals to 0.3 square meter and V is equals to 20 meter per seconds. Thus, M equals P times V times A. M is equals to 1.5 times 20 times 0.3. So, M is equals to 9.0 gram per seconds. So, the mass flow through the tube is equals to 9.0 grams per seconds.
Hello, my name is Rio Narciso and I'll be reporting the volume flow rate. So, volume flow rate is the term used in physics that describes the flow of some volume of some matter. It means it gives the flow amount in terms of physical dimensions, but not mass moves through space per unit time. This amount is considered as the flow rate. The term volume flow rate almost always applies with liquid and gases, but not for solids. Although solid even can move from some steady rate. What is volume flow rate? Flow is a common phenomenon in physics for liquids and gases. We have heard the term volume flow rate many times. The volume flow rate of a fluid can be defined to be the volume of fluid which is passing through the given cross-sectional area per unit. Here, cross-sectional area means the area through which something is flowing. Because liquids are incompressible, so any portion of liquid flowing through a pipe could change shape, but still, it will maintain the same volume. Even this is true if the pipe changes its diameter, so the volume flow rate for an incompressible fluid at any point along a pipe is the same as the volume flow rate at any point along a pipe. So as volume flow rate measures the amount of volume that passes through an area per time, therefore, equation for the volume flow rate will look like the ratio of volume to time. It turns out that there is a useful alternative for writing the volume flow rate like this. As rate will be high when the pipe becomes narrow, it means that fluids speed up when they reach a narrow section of a pipe and slow down when they reach a wider section.
Here, I am going to use a specific example to illustrate the relation between the volumetric flow rate and the average velocity and the cross-section, this relation. Imagine we have a block of a fluid that's about to go through the cross-section, and this block of a fluid is 1 meter long in the duct, and the duct cross-sectional area is 1 square meter, and the average velocity of the fluid is 1 meter per second. So, as we can see, the volume of this block of a fluid is of 1 meter cube, and also it's easy to see that it takes 1 second for this block of a fluid to go through this cross section. So, the volumetric flow rate is equal to 1 cubic meter divided by 1 second, and this is equal to 1 meter per second, the average velocity, times 1 meter squared, the cross-sectional area. So this is a very special example, but this shows us that the velocity, the volumetric flow rate, is equal to velocity average times the cross-sectional area. We use a special case to illustrate the validity of this equation, but this equation actually is applicable for any cross-section in control volume. It's not limited to a duct with constant diameter. So here, in this brief lecture, we review the mass flow rate, volumetric flow rate, velocity, and cross-sectional area. Here, the velocity refers to the average velocity at cross-section, and the mass flow rate is written to the volumetric flow rate through density of this equation. And the volumetric flow rate is equal to the average velocity times cross-sectional area in the control volume.
Volume flow rate is represented by the symbol Q, with unit as m cubic meters per second. Therefore, the volume flow rate formula can be written as volume flow rate is equal to variation of volume over variation of time, where Q is the volume flow rate, delta vol is the volume of the fluid that is varying, and the delta T is the variation of time. Here are the example for volume flow rate. Question number 1. A fluid is flowing through a tube which has a transverse area of 0.3 square meters. All the fluid in the tube of 30 cm flows to a container in a period of 5 seconds. Determine the volume flow through the tube using volume flow rate formula. The total volume of the fluid flowing is given by the formula as Q is equal to delta vol over delta T. So the given parameters are delta vol is equal to 0.3 m squared times 0.30 meters, product of flow length with cross-sectional area. So 0.3 m squared times 0.30 meters is equal to 0.09 cubic meters. So 0.09 is equal to 90 liters, as 1 cubic meter is equal to 1,000 liters. So 0.09 is 90 liters. And the delta T is equal to 5 seconds. So therefore, applying the formula, volume flow rate is equal to 90 divided by 5 is equal to 18 liters. Therefore, the volume flow rate will be 18 liters per second.
Good day everyone. In this video, we calculate the average fluid velocity in a pipe in terms of the volumetric flow rate of the fluid, steady turbulent flow, and it's very common in mechanical energy balance. So in a pipe, we draw a pipe with fluid coming through it. I call the sectional area a cross section. And the volumetric flow rate, capital V, dot. So that's volume per time, maybe it has units of meter cube per seconds. So in steady turbulent flow, that will result in there being a very constant velocity profile. So all the fluid will be moving at the average velocity. So the average velocity, units of something like meters per second, and the area of cross-section will have units something like meters per squared. So we want to relate the average velocity and the volumetric flow rate. So we just think about a time interval and say a time interval delta t. It has passed through some parts of the pipe, so it would look like a little bit like this. There will be fluid entering and exiting over the time interval delta t. The fluid will be travel a distance L, which will be average velocity times the time interval. So this is meters per second, so many seconds, that would go so many meters. The cross-sectional area, excess the cross-section of the pipe. So we calculate the volume of the fluid that passes through the cross-section in the time interval delta t. We have the volume of fluid that passes through the cross-section will just be the area of this right circular cylinder. So that's the area of the base times the height. So there's a volume. Let's check the units. Meters squared, meter per second times second, so meters cube. And then to get the V, we're just going to move the delta T to the other side. So the volumetric flow rate, the volume per time is going to be volume times the interval, and so that's just going to be a XSA average B. That's the very simple relationship, but sometimes it's one that we miss. We can always calculate for steady turbulent flow. We can calculate the volumetric flow rate from the cross-section, sectional area times the average velocity, or conversely, we could calculate the average velocity as this volumetric flow rate divided by the cross-sectional area. That's really useful relationship in for study turbulent flow, because we often have one able to measure the volumetric flow rate. We know the cross-sectional area in that flows. As to get the average velocity again, this is the limited to turbulent flow, steady turbulent flow, but that is very common circumstance in engineering practice.
Hello everyone, I'm Edelmira Navarro and I'm going to discuss to you this given question that we will be solving and determine if the flow is laminar or turbulent. Now, if we need to determine if the flow is going to be laminar or turbulent, we need to work out what the Reynolds number of the following liquid is going to be. Because we know that if the flow or if the Reynolds number is higher than 40,000, then we can say that the flow is turbulent. That means that water is just going in all directions. Just like you can see here, whereas if the Reynolds number is less than 2,000, that means that the flow is more than laminar. That means it's flowing like a straight line coming out of the pipe. And formula to work out Reynolds number is RE is equals to VD divided by MU. In here, the rho represent the density, V is the velocity of at which the fluid is traveling, D is diameter of the pipe, and MU is the viscosity of the fluid. We know that it is the water that's flowing, so that means the density is going to be 1,000 kilogram per meter cube. The velocity at which is traveling is not given to us in this question, so we need to find it. The diameter is given and the viscosity as well given. So how can we work out that the velocity will be? Well, for that, we can use the equation for the flow rate, which says Q equals VA. That means flow rate of the fluid is equal to velocity times the cross-sectional area through which of the fluid is flowing. Now, how can we use work out this cross-sectional area? Well, the question, the diameter is given to us. What is the diameter? It is 40 millimeters, so I can write diameter is going to be 0.040 meter just to convert everything to standard units. And to work out the area, we can just use the area of a circle, which is pi r square, and that will be the pi times 0.040 over 2, the entire thing, the whole square, y divided by 2, because it is pi r square. The diameter divided by 2 will give us the radius. Working this out will give us the area to be 0.00125 meters squared. Now that we know the area is, you can see that in here, the flow rate is given to you is the liter per second. Again, I'm going to convert that into the meter cube per second. Q equals 1 liter per second, dividing that by the 1,000 will give us 0.001 meter cube per second. Now, substituting all of the back into his equation will give 0.001 is equals to the velocity times the area that we found to be 0.00125. So we can work out the velocity to be 0.001 divided by 0.00125, which will give us 0.8 meter per second. Now we know the velocity at which the fluid is traveling. Next, we can substitute this value for velocity into the equation to find the Reynolds number, so we can write RE is equals to density of the water 1000 times the velocity, which is 0.8 times diameter of the pipe again. We got to write that in meters, so that's going to be 0.04, the entire thing divided by the dynamic viscosity, or just viscosity, that's given to us over there, 0.001. Putting this into calculator and working out the answer will give us the Reynolds number to be 32,000. Now, obviously, 32,000 is way more higher than 4,000. Therefore, the flow in the pipe is turbulent flow. So if we get a Reynolds number of more than 4,000, the flow will be turbulent flow.
Water flows in a steel pipe. Diameter is 50 mm. The mu is 0.002 kilogram per meter seconds with the rate of 1 liter. The formula for this is equals to rho Vd divided by mu. Since the velocity is missing, let's use the equation for the flow rate, which is u equal to v. That means the flow rate of the fluid is equal to the velocity times the cross-sectional area through which the fluid is flowing. A indicates as diameter. Let us solve for to make everything standard unit. We'll make millimeter to liter. Diameter is 50 millimeter. To make this standard unit, B is equal to 0.050 liter. Then area is equal to pi r square. Times 0.050 divided by 2. The area now is 0.00125 Now we can know the area is, we can see that the flow rate is given, which is 1 liter. Now we'll convert it to liter. To make it standard form, we're now dividing that to 1,000, which will give us 0.001 seconds. Then let's complete now the velocity. Velocity V is equal to U divided by F. Since our Q is V is equal to velocity is equal to 0.00196 meters squared. Now we'll get 8V is equal to 0.89 meter per second. So let's determine now which is 2 to the